Hi, welcome to Algebra 2 Common Core. Today we're going to begin Unit 2 with Lesson 1 on average rate of change. Let's start with the function given by the graph shown in your notes. We want to evaluate each of these function values by looking at our graph. So for example, we know that f of 0 is going to be this coordinate right here. So we want to evaluate the y-coordinate when the input is equal to 0. Clearly, this y-coordinate is equal to 1. At an x-coordinate of 4, here is my point. So when we count on the graph, it turns out that f of 4 is equal to 7. Go ahead to f of 7, which would be this point on my graph. So the function value at 7, if we count it out, turns out to be 10. And the last coordinate that we're looking for is this one over here. When the x-coordinate is 13, the function value is equal to 15. We're going to be using those points throughout our first exercise today. For part B, it says find the change in the function value given each interval. So we are looking for what the change in the function value is. Sometimes we write that as delta y or delta f of x. Delta is a Greek letter of the alphabet. It's written as a triangle, and it actually means the word change in. So we want the change in the function value from 0 to 4. That just means that we want to find the function value at 4 and subtract the function value at 0. So the function value at 4, as we see above, is 7, minus the function value at 0 is 1. So that change in function value is just 6. Likewise, if I want to find the change in the function values on the interval from 4 to 7, I want to evaluate f of 7 minus f of 4. So f of 7 from above is 10. 10 minus f of 4 above is 7. 10 minus 7 gives me a change in the function value of 3. To do the interval from 7 to 13, we want to do the function value at 13 minus the function value at 7. Looking at our function values, I'm going to say 15 minus 10, which is an answer of 5. So in each case, we just evaluated the change in the function value given the interval that we were looking at. For part C, we have to actually consider something else. What other value do we need to consider when determining over which interval the function is changing the fastest? Well, clearly we have looked at just the change in the function value. But when we want to decide when the whole function is changing the fastest, we also need to consider that the x-coordinate is also changing. So if the x value is also changing, that has to be taken into account as well. So throughout this lesson, we are looking at the definition of the average rate of change. You're going to need to pause the video for a minute while you copy down the definition for average rate of change. The average rate of change is how fast a function changes, on average, over a certain domain interval. So pause the video and write down this definition, and then start the formula. And then come back and we'll finish the formula. So if we want to know how fast a function changes on average over a certain domain interval, we're going to be looking specifically at that domain interval from A to B in this case. Our definition for the average rate of change is going to be the change in the function value divided by the change in the x value. That's our domain value. So in words, this is the change in the output, or our y values, divided by the change in the input. So the calculations that we will have to do, we will have to find the function value at the right-hand endpoint of our interval, f of b. We'll subtract the function value at the left side of our interval, f of a, and we'll divide by the difference of the x-coordinates, which is going to be b minus a. This is a really important formula for us throughout this year, so please make sure that you highlight this in your notes and pay particular attention to the following examples where we go over this formula. So let's finish exercise number 1, where we're going to calculate the average rate of change for the function over the intervals that we have been looking at. So if we want the average rate of change over the interval from 0 to 4, we have to calculate f of 4 minus f of 0 divided by 4 minus 0. We already know from our calculation above that f of 4 minus f of 0 turned out to be 6. When we subtract 4 minus 0, that's giving us a 4. So that tells us that our average rate of change over the interval from 0 to 4 reduces to 3 over 2. Let's look at that same formula for average rate of change, this time from 4 to 7. So we're going to do f of 7 minus f of 4 over 7 minus 4. F of 7 minus f of 4 we calculated above to be 3. Our denominator 7 minus 4 is also 3, so 3 divided by 3 is equal to 1. For the last interval, if we want to calculate the average rate of change from 7 to 13, we want to do the function value at 13 minus the function value at 7 divided by 13 minus 7. We've already calculated f of 3 minus f of 7 in this case to be 5. 13 minus 7 gives me a 6. So we can see that the average rate of change is different for all of the intervals that we are looking for this function, given the graph of the function. Hopefully you recognize that average rate of change as actually just the slope of the line that connects those points on my graph. So we're going to go ahead to our graph and we're going to draw in the line segments that represent those slopes. So for the first interval from 0 to 4, I'm going to connect the point at 0 to the point at 4, and I should see that the slope of this line segment, m, is actually equal to 3 over 2. I could count that out as well. Up 3 over 2, up 3 over 2, giving me that slope. Notice that I had to do it twice because that calculation, when I did it, turned out to be a reduced value. Go to the next interval, so the interval from 4 to 7. I'm going to connect this point to this point, and that slope turns out to be 1. So the slope is 1 because I'm going up 1 over 1, up 1 over 1, up 1 over 1. That also was a reduced answer for my slope, showing me that I had to do the count 3 times. Finish it off with the last interval from 7 to 13. So I'm going to connect this point to this point, and again, if I count that slope, I see that I get exactly the same answer, 5 over 6, up 5 over 6. So the average rate of change is seen on my graph as the slope of the line segment that connects the points on the interval. So in our first example, we could see that we calculated the average rate of change using an equation for f of x. So if we have the equation for f of x, or any function, then we're able to do f of b minus f of a over b minus a, and that calculates the average rate of change. Likewise, we could use points on a graph, and when we are using the graph, we can just take the slope of the line segment that connects the endpoints. Lastly, we could also use a table of values or a list of coordinates. If we have a table of values, we are still going to calculate the average rate of change by doing the formula f of b minus f of a over b minus a. So today we're going to get some practice in calculating average rate of change in all three ways. In exercise number 2, we're going to use two different functions. F of x is 5x plus 7, and g of x is 2x squared plus 1. We're going to calculate the average rate of change in the table in your notes for each of them. Let's do one together, and then I'll have you do the rest and compare your answers with mine. So together, let's do the interval from -2 to 3. Let's start with the function f of x, which is f of x equals 5x plus 7. So we first of all need to calculate the function value at -2 as well as the function value at 3. So at -2, the function says let's do 5 times the input. So 5 times -2 is -10. -10 plus 7 is -3. The function value at 3, 5 times 3 is 15. 15 plus 7 is equal to 22. So we need the function values at the endpoints. Now we're going to do f of 3 minus f of -2 over 3 minus -2 to get the average rate of change. That tells me that I've got 22 minus a -3 divided by 3 minus -2, which is 5. 22 minus -3 is 25. 25 divided by 5 is equal to 5. So the average rate of change on that interval for f of x is equal to 5. Let's look at the function g of x on the same interval. So remember that our g of x function is g of x equals 2x squared plus 1. So I want to calculate g of -2 by plugging -2 into the function for x. -2 squared is 4. 2 times 4 is 8. 8 plus 1 is equal to 9. Let's do the function value for g at 3. 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. So the average rate of change for g of x, we need to do g of 3 minus g of -2. Notice that we're always taking the bigger endpoint minus the smaller endpoint, all divided by 3 minus -2. So 19 minus 9 gives me 10. 10 divided by 5 tells me that my average rate of change is equal to 2. Now I want you to pause the video. Please come back when you're done and do the calculations for the average rate of change for f of x and g of x on the last two intervals, filling in the complete table. Please check your answers for the average rate of change for f of x and g of x over the intervals given. Go back and make any corrections that you need to if your answers don't match mine. Now, hopefully you observed that all of the answers for the rate of change for f of x turned out to be 5. What might account for this? Think about it for a minute. However, g of x, all of the answers turned out different. Why would the answers turn out different for g of x? It has something to do with the type of function f of x and g of x each are. we see that f of x is a linear function. With a linear function, the graph is a line, and therefore the slope is constant. If the slope is constant, then of course that tells us that the average rate of change is going to stay the same no matter what interval I look at for that function. But when we look at g of x, we see that g of x is not linear. In fact, g of x in this case happened to be quadratic. For any quadratic function, the slope is not constant. We happen to look at it at 3 different intervals where the slope was increasing. So we see that the average rate of change went from 2 to 12 to 24. This is actually a really important topic for the future in your math courses, but it's something that we'll be coming back to quite a bit in Algebra 2. So it's really important that you understand how to calculate an average rate of change and also the difference between different functions and what happens with their average rate of change. Exercise number 3 is somewhat of a challenge problem. If you'd like to, you could stop the video and try to fill it in on your own. If you don't quite know where to start, keep watching the video and I'll explain the first few steps. We see that this table represents a linear function. If we see that it's a linear function, that tells me that my slope, or my average rate of change, is going to be constant no matter what interval I look at. So I want to calculate the change in y over the change in x over intervals that I am given. So for example, if I am looking at the first 2 ordered pairs, the change in y, I see that I'm going from -5 to 1, which is a change of 6. I could do that as a subtraction as well by saying 1 minus -5. But when I look at the change in x, I'm going from 1 to 5. That's a change in 4. I could also have done a subtraction there. 5 minus 1 gives me 4. So for this table, I have to keep a consistent change in y over change in x of a reduced value of 3 over 2. So every time I increase by 2 on the x value, I'm going to have to increase by 3 on the y value. So let's look at the next set of ordered pairs. Going from 5 to 11, I see the change in x is equal to 6. But if I look at my y value, I don't know what I have to change by, but I do know that altogether it has to work out to be a change of 3 for y and 2 for x. We can consider this as a proportion, so I could cross multiply and say 2 times the change in y is equal to 3 times 6, which is 18. Dividing by 2, the change in y has to be equal to 9. So if I'm starting in a y value of 1, I need to change by 9 and bring it up to a y value of 10. Go back and do the calculation. So the change in y, 10 minus 1, the change in x, 11 minus 5, that gives us 9 over 6, which does reduce to 3 over 2. So I correctly calculated that the change in the y value had to be 9, so that told me that I had to add 9 to the 1 in my table. Let's go to the next pair. I see that going from 10 to 22 gives me a change in my y value of 12. I don't know my change in my x value, but I know that throughout this table it has to be 3 over 2 for my average rate of change. Treat this as a proportion, so 3 delta x is equal to 2 times 12, which is 24. So therefore the change in x has to be equal to 8. So that tells me that going from 11 to my next x value has to be a difference of 8. So this value has to be 19. Again, if I check that, the change in y, 22 minus 10, divided by the change in x, 19 minus 11, does give me 12 over 8, which reduces to an average rate of change of 3/2. Now, I can only do this kind of calculation if I've got a linear function because I know that my average rate of change is constant. Take a second, stop the video, and see if you can find the last missing value. Hi, welcome back. Did you get that the last y value should be 61? Take a look at the work that I did to calculate that. I found out that the delta y value had to be 39, and I added 39 to 22, giving me a function value of 61. When we check that, 61 minus 22 divided by 45 minus 19, if I do that calculation, I'm getting 39 over 26, which does reduce to an average rate of change of 3/2. If you have any questions, come and see me in the morning, but we'll continue to work on this in our next lesson.